Good afternoon, dear colleagues. I'm very glad to be here today with you and have a few words about Quantitative EEG with Neurospectrum.net software. My name is Alexey Ivanov and I'm EEG Product Manager in Neurosoft company. Here is my agenda for today. First of all, we will say a few words about what is qEEG. We tell a few words about EEG mathematical analysis, topographic maps, trends, EEG export, and 3D source localization software. So, what is this quantitative EEG? Since 90s of the last century, various methods of computer-based analysis of EEG was used in clinical practice. First of all, it is useful to compare EEG of different patients or of one patient after few examinations with the digits. Modern computer systems for EEG recording also have a large set of mathematical methods for analysis and quantitative EEG signal. So compare EEG with native EEG traces is not easy task, but if we have a computer-based analysis, if we have digits instead of native EEG traces, we can easily compare EEG of different patients or EEG of one patient one by time. And after comparing, we also can make some recommendations of treatment such EEG, for example, with such methods like neurofeedback, transcranial magnetical stimulation, transcranial direct current stimulation, and others. So, what EEG mathematical analysis we can use? First of all, we need to say that it is not an easy task to record clear EEG signal. Usually we have a lot of artifacts on our examinations. That is why we need to pre-select clear EEG episodes, so-called epoch of analysis, to send these epochs to analyzing, to mathematical calculations. Or we can also have so-called express analysis, which can analyze a visible or selected part of EEG traces. And one of the first EEG analysis is amplitude analysis. It means that we can calculate EEG waves from peak to peak or from isoline to peak and calculate minimum, maximum, and average amplitudes of each wave in our recording. For example, on this slide you can see the momental map and momental measurement of EEG traces. From the left side you can see the digits of momental amplitude of selected moment of EEG, and also we can see this map built based on these digits. Also we have so-called wave measurement mode, when we can select part of EEG trace, and we also can see here the maximum EEG amplitude, average EEG amplitude, and also some spectral analysis results. I'll show you how it looks in real EEG traces. For example, here we can see clear EEG with good alpha rhythm. We can also mark some episode like an epoch, for example like this. I can select one epoch, another epoch, where I can see clear EEG. I can press left mouse button and choose the epoch, like this and this. Then, using analysis main menu, I can open instant amplitude, for example, as on that slide. I can move this red line and you can see results of measuring from the left side with digits and in the center with the momental map. Also, we can use so-called wave measuring mode. When we can select part of EEG trace, and software will calculate different parameters. For example, maximum EEG amplitude 94 microvolts, average EEG amplitude for this episode 63 microvolts, and also selection time, domination frequency, and other spectral parameters. Also, we have another tools for amplitude analysis. For example, amplitude scanning, when we have a topographical maps one by one after selected interval of time, and we can see how EEG activity change during this time. Also, we can calculate rhythm amplitudes with this window, analysis, amplitude analysis, rhythm amplitudes, where we can see the digits for each band. For example, delta, theta, alpha. We can calculate maximum amplitude, minimum and mean, and asymmetry. For example, I choose maximum amplitude. For each derivation you can see the calculated alpha rhythm maximum amplitude. And also we can go to maps page and can see here our amplitudes. And on the diagrams we also can see results of calculations. Another part of EEG analysis, important part, is spectral analysis. It is based on Fourier transform and can show us the spectral graphs and frequencies in our EEG traces. To open this, we can use analysis main menu, spectral analysis, and for example spectral graphs. Here you can see results of epoch analysis results, or I can also choose express analysis. In this case, software will calculate spectral graphs for visible part or for selected part. If I select some EEG part with left mouse button, software will calculate selected fragment, duration 20 seconds, and it is express analysis. But I always can switch to epoch analysis also. And here, if I select, for example, this frequency, I can see first of all the dominant frequency. I can see where it is located. It is in occipital durations, 01, 02, the maximum power frequency of this alpha rhythm band. Also, we can see here the list of different spectral parameters which software also can calculate for spectral analysis. A few words we should say about topographic maps. According EEG is recorded from electrodes which are placed according international 1020 system. We can know exactly where each signal was recorded. That is why we can build so-called topographical maps. For example, we can calculate some digits, some values, for example, maximum amplitude or total alpha power, or for example, dominant frequency and any other parameters. We can calculate these digits for each derivation, as you can see here. And then using this color line, we can recalculate each point of our brain according to these digits. And we will get like these topographic maps. For example, on these maps, we can see that alpha rhythm power is maximum on occipital derivations, and maximum value is 209. Also, we can choose another color lines to build another topographical maps. And for sure, we can use two-dimensional and three-dimensional topographical maps for better resolution. Few words about trends. Another useful tool which helps us to analyze EEG traces much more faster is trends. For example, if we want to review long-term EEG examination, it will take a long time for review these traces. I can show you with another examination. For example, here it is only 3.5 hours of recording, but it's very long time to review all native EEG traces. But if I have some trends which are calculated according all my recording. You can see here 3 hours and 40 minutes here, and all my record is on one screen, and I can move very easily through my examination only with one mouse click. For example, you can see here density spectral array on the top and rhythm index ratio on the bottom. And for example, here we can see some red area with high amplitude. Here we can see normal voltage. And for example, here we can see some alpha band activity. But when we use, for example, this high amplitude, we can find here it is artifact. But if we switch, for example, to another examination, I'll show you how we can easily find, for example, epileptiform activity. Here you see in the central part, if we choose, for example, this peak, we will find epileptiform activity. For example, another peak. Also the same. You can see that now we can choose it and define it as epileptiform activity. It is very easy to see all EEG recording. For example, here it is 4 hours recording. We can see all this recording here in only one screen. It is very helpful. So, I already told what is it, trance. Also, we can use, for example, Persist software. It is USA software, very famous in the world, and it is can works directly in neurospectrum.net software. We have full collaboration with this trance software. Also, Austrian Institute of Technology, so-called NService neurotrend software, also can calculate different type of trends for EEG, and we also collaborated with this software. Here you can see a slide with Nicolet trends and neurospectrum.net trends also. Here is a small description. For example, we can see native EEG traces, we can see timeline for our trends, we can see scales, we can move through our trends, and we can see some informational panel for each our trend. In neurospectrum.net software we have a lot of different trends. You can see here the list. It is not full list. We can choose different parameters in the trends, for example, density spectral array, delta, theta, alpha, beta rhythm indexes ratio, spike activity, and many others. Here is the list of available EEG trends in neurospectrum.net software. Using, for example, density spectral array, it is very easy to understand the long recording. For example, here with red color we can see that delta rhythm activity is probably bigger here, and here we can see the alpha rhythm activity, because it is green band is for alpha, red for theta, and brown for delta, and upper is beta rhythms. And for example, also with the white color we can see the so-called dominant frequency. It means the peak of frequency with white color here. We can see how we change from first part of our recording, it's first hour, and the second hour the dominant frequency is lower, because here is delta rhythm activity is much more powerful. Another example, it is the spectral age, so-called spectral age, with which measures like 95% of all power of spectrum. And here, for example, we can see that it is in a beta range, and on the other side, from the right side, we can see that it is lower. It means that much more power of spectral goes to slow activity, and it is also clearly seen here. Here we can see alpha band activity, and now on the right side it is a delta rhythm activity. Also we have rhythm index, so delta, theta, alpha and beta indexes, and in rhythm indexes ratio, and also like this, where brown is delta, red is theta, green is alpha, and blue is beta rhythms. Also, we can clearly see that, for example, in the start we have big alpha, then we have a big delta activity. And here we can see the comparison of spectral graphs from the left side and from the right side of the examination. Another kind of trends is average EEG amplitude, or so-called envelope, where we also can see the average EEG amplitude, and very easy to navigate to parts where amplitude is bigger. We also can compare it with left and right hemisphere with blue and red color. Maximum EEG amplitude trend. Number of spikes and sharp waves, also very helpful trend which can help us to review epileptiform activity very fast during long-term EEG activity. Total power spectrum trend shows us the spectral activity of all EEG band. And also very important trend, so-called AEG, or amplitude integrated EEG trend, which widely used in clinical practice for critically ill patient in intensive care units, and especially for neonatal ICU. Using this trend, we can clearly see the minimum and maximum amplitude of EEG activity, and we can also see the so-called patterns of this trend. It can be continuous normal voltage pattern, discontinuous voltage pattern, burst suppression, isoelectric patterns, and others. For example, on this slide you can see how this trend is calculated. On the one trend we can see both minimum and maximum values for each epoch. And here you can see a few different patterns. For example, here is epileptiform activity, here is a burst suppression, and here is a rare epileptiform activity patterns. Also, using this trend, we can see wake-sleep cycle, and here is continuous normal voltage pattern and discontinuous normal voltage pattern, where the minimum and maximum amplitudes are quite bigger. And other patterns, for example, nearly isolectic patterns, shows us that electrical activity of the brain is very low, and it is very negative pattern for prognosis for such patient. EEG export is also a very important part of any modern EEG software, because not any analysis we can use in our EEG software, but we can use, for example, so-called external or third-party EEG analysis softwares, for example, MathLab, EEG Lab, Simulink, and OpenVibe, and others. And for example, in our software, Neurospectrum.net software, we have two different formats for export, which are widely used all over the world. It is so-called EDF plus European data format, and LSL, Lab Stream Layer Protocol. Using these two export methods, you can export EEG data both in online or offline to third-party EEG analysis software. What kind of software you can use? For example, iSync Brain. It is a web-based qEEG software which allows you to upload EEG recording to the website, to your page, and can calculate very huge part of different qEEG parameters, build topographical maps, build 3D localization of source activity, build different statistical and normative waves comparison analysis. Another kind of software is Epilogue Pre-Op. It's Belgian system, which also can calculate and compare your EEG with normative database and give some recommendations for these patients for treatment. qEEG Pro is Dutch system with the same functionality, which can compare uploaded EEG in EDF format with normative database and say what parameters are not in good condition for this EEG. NeuroGuide software from USA, it's very widely used software with a big number of different calculations and analysis, and our EEG devices can work with NeuroGuide directly, or you can also upload EEG via EDF format to this software. HBIDB, it is also normative database where you can compare your EEGs with normative EEG values. BESA, it is a German software with lots of different mathematical calculations of EEG. And at the end of my speech, I'd like to show you few 3D source localization software which helps using EEG find the three-dimensional source of localization. It is BrainLog software from Russia. It is collaborated with neurospectrum.net software, so you can just select EEG traces and export it to BrainLog software. Another software is Loretta, well known in the scientific area, which is widely used for different researches. And we also have a full collaboration with this software, and you can export EEG from our software to Loretta with no problems. And another software for 3D localization of source, electrical source in the brain, it's Ensevis EpiSource software, which is also can be used directly from neurospectrum.net software. So using quantitative EEG analysis, we can compare a different part of EEG. We can compare EEG of different patients, and using European data format and LabStream layer protocol, we also can make different researches and analyzing in third-party software. And using qEEG, we can find a small difference between EEG traces and can recommend a different treatment according to these digits, for example, biofeedback, transcranial magnetic stimulations, and TDCS. That is all I wanted to show you for today. Thank you very much for your attention.